Okay guys, so our next lesson involves examining and exploring the relationship between current, voltage, and resistance, which is known as Ohm's law. Okay, so it says here, recall, current is the movement of charges. So remember guys, current is the flow of electrons or the flow of electricity measured in amps. So remember with the water tank analogy, we said that charge is represented by the water. So electrons, being those charges, is represented by the water in the water tank. And current is represented by the flow of that water in the water tank. Okay, so if we have a higher charge, then we're going to have a higher flow of water or flow of electrons or electricity. So again, current is representing the flow of water in the water tank. Then we have voltage, also known as potential difference. Okay, this is the difference in the amount of energy per unit of charge between two different points. Okay, the difference measured in volts. So when we looked at our water tank analogy, voltage is represented by water pressure. So up in the tank here, the water pressure is greater, whereas down in the hose, the water pressure is lower or has decreased. So this is to show how the voltage is the difference in energy at 2 points in a circuit. Also, it's important to note that as water pressure increases, so does the flow of the water. So this goes to show you that as voltage increases, so does current. Or as voltage decreases, as the water pressure decreases in the tank, the flow of water decreases as well. So if voltage decreases, so does current. Okay, now we're going to talk about resistance. So resistance is a material's ability to oppose or slow the flow of electrons. And remember, the flow of electrons is current. Okay, so resistance is when something is trying to slow down the flow of electrons. So in our water tank theory, if say sand or rocks were added to that water tank, those would slow the flow of the water, which we know the flow of water is represented by current. Okay, so those would be an example of resistance slowing the flow of electrons. Here the example is water dam, which is another perfect example. We always say that current is like the flow of water or the flow of water down a river or a stream. And a water dam would be something that slows the flow of electrons, adds resistance, okay, or decreases the flow of electricity. We use a device called an ohm meter connected to the circuit to measure resistance, and the units of measurement for resistance is ohms. Okay. Okay, a resistor is a common device that is used to create resistance. Okay, and again, resistance is reducing the flow of electrons or electricity. So a resistor is used to reduce the flow of electricity. Okay, it implements resistance within a circuit and controls the flow of electrical current or electrons. Okay, in real life, in electrical circuits, resistors are sometimes added to protect against voltage spikes. Okay, and I'm sure you guys have heard of something where like a fuse has been blown. Okay, so that can be when too many things are plugged in and being used, and sometimes a resistor can help with this. Okay, so something that's added into a circuit to control the flow of electricity or to reduce it, slow it down. Okay, so there are different factors that affect resistance in a circuit. So number one is type of material, the ability to conduct electricity, or how freely electrons can move within the material. Silver is a good conductor. So the type of material is definitely going to affect resistance. If you're using a very good conductor, so say silver or copper wires, then that is going to decrease the resistance. But if you were to use a material or substance that's not the best at conducting electricity, that's going to slow the flow of electrons. Next is cross-sectional area. So the larger the diameter, the less the resistance. Okay, so as you increase the diameter of a conducting wire, resistance is going to decrease. Okay, if you decrease the diameter of a conducting wire, then that is going to increase the resistance. Length, okay, the longer the wire, the more the resistance. Okay, so if you think about it, the longer the wire, the further the electrons or the current has to flow around the circuit. So if you make the circuit bigger, that's a longer wire, and that's going to add resistance. It's going to increase resistance. So if you increase the length, resistance increases. If you decrease the length, resistance decreases. And lastly, temperature. Resistance increases as temperature increases. Okay, so as the temperature goes up, so does resistance. If you have a lower temperature and you're decreasing it, then resistance is also going to decrease. Okay, so this brings us to Ohm's law. So Ohm's law, again, is the relationship between current, voltage, and resistance. As the length of a wire increases, okay, as the length increases, current decreases and resistance increases. So this is exactly what we saw in the last slide. If the length of the circuit or the wire increases, that means that the current or the electrons have further to travel. So that's going to decrease current but increase resistance. As potential difference or voltage across a load increases, so does the current. Okay, so as one increases, so does the other. So as voltage increases, so does current. And remember, we saw this with our water tank analogy. As water pressure increases, which was voltage, so does the flow of water, which was current. Okay, so we are going to learn a new triangle that we use for different calculations. So V is representative of potential difference or voltage. Okay, and we measure potential difference in volts. That's the unit of measurement. I is representative of current. Okay, and we measure current in amps. And R is representative of resistance, which we measure in ohms. Okay, and ohms is this little symbol here, guys. So when drawing ohms, something that looks like this is perfectly fine. Okay, V for potential difference, I for current, R for resistance, and then we have all of our units of measurement there. Okay, so Ohm's law, here's the Ohm's triangle, and recall, cover the variable you are being asked for, and the remainder provides your equation. So we're good at this now. We use the density triangle for the same thing. So when trying to find resistance, we are going to cover the variable you're being asked for. So if we're looking for resistance, we're going to cover it, and then we're going to use what's left over. So remember, this line here means divide. So R equals V divided by I. So resistance equals voltage or potential difference divided by current, okay, because I represents current. If we want to find V, I'm just going to get rid of this. If we're looking for voltage, then we're going to cover up V, okay, and then whatever is left over. Remember, this line here is representative of multiplication. So V equals current times R, because they are side by side, not above each other. Okay, and lastly, okay, if we're looking for current, which again is representative by I, we're going to cover it up and whatever is left over. So we have V divided by R, okay, which is right here. Okay, so now we're going to use this triangle to answer some problems, which you guys will have some practice of this in your booklet. So it says here, how much resistance Okay, so how much resistance does a light bulb create if it has a current of 0.025 amps around it in a 9-volt circuit? Okay, so in order to do these types of questions, guys, we're going to use DESCA. So remember, DESCA is data, equation, substitution, calculation, and answer. And we're going to go step by step. So data is writing down what we have. So remember, use your units to help you, as well as keywords. So it says how much resistance. So that means we know we're trying to figure out R. Okay, and it says has a current. Okay, so I represents current in the formula. So I is 0.025 amps, and voltage, which we know V represents volts, the unit of measurement. So voltage is 9 volts. This should not be here. Get rid of that. Okay, so we have I, we have current, we have voltage, and we're trying to find resistance. So if we're looking for R, we're going to cover up R. And what are we left with? V divided by I. So that's why we have our equation here. R equals V divided by I. Now we're going to sub into the equation. So V is 9 volts divided by I, which is 0.025. So 9 divided by 0.025, if you were to sub that into your calculator, you would calculate to 360. And remember, we're calculating resistance, so you have to add the units for resistance, which are ohms. Okay, and then your answer, therefore, the resistance is 360 ohms. Okay, let's do another one. So it says here, calculate the current. Okay, calculate the current if the battery has a voltage of 3 volts and the resistance of the light bulb is 0.5 ohms. So we're going to pick out what we have. So we know calculate the current. So we want to find I, because I represents current. They gave us voltage or potential difference, that's 3 volts, and they also gave us resistance, which is 0.5 ohms. So if we're trying to find I, we're going to cover it up, and whatever is left over, which is V divided by R. So B, sorry guys, I equals V divided by R. Now we're going to sub into the equation. V is 3 volts, R is 0.5 ohms, and calculate, we get I equals, if you calculate 3 divided by 0.5, you should get 6, and we have to use our unit of measurement for current, which is amps. So we get 6 amps, therefore the current is 6 amps. Okay, so again, using DESCA, using your ohms triangle, writing down what you have, subbing into the equation, and getting your answer. Okay, you guys have a little bit of practice on pages 29 to 30 in your booklet. Thanks, guys.